your next challenge is entitled Next Prime. Given an integer, create a function that returns the next prime. If the number is prime, return the number itself. Let's look at the examples. They give us 12, which definitely is not prime. An even number would not be prime, besides 2. Remember that a prime number is one whose only factors are 1 and the number itself. So a number like 25 would not be prime because in addition to 1 and 25 as factors, it also has 5 times 5. So 5 is a factor as well. And then, of course, with the input 24, that's not prime, so you basically go in increasing order until you find the first prime number from the starting point. The third example shows that if you are past a prime number, to just return that number itself. You don't need to find the next one. You should return the number provided if it's prime. So those instructions are pretty clear. We'll head over to code and go ahead and give this one a shot yourself, and when you're ready, come on back. I'm going to make a helper method for this that's going to do the work of determining if a number is prime or not. So I will return a boolean. Let's call this is prime. It'll take a number. And then let's think about how to calculate a prime or determine if a number is prime. What do we know? So we'll say that if num is less than or equal to 1, that's going to be not prime, right? The first prime number is 2, and it goes up from there. So any lower input, we're going to say no dice. I don't think negative numbers are prime, so we'll just do that. And then also a quick check would be is if the number is even, right? If number modulo 2 equals 0, that's another case where we know right away we're not talking about a prime number here. Okay, so we got some of those out of the way. We can return the special case that number is exactly 2. It's unique in that it's an even number, so let's do a check for that. If we happen to have that input, we'll just say true. Okay. Now, to sort of not do more checking than we have to, I'm going to take the square root of the number to determine how far up to look, starting from 1 when I'm searching for factors. And if I take the square root, that will get me the biggest unique factor before I start looking at repeats. So if I can explain that, consider the number 36, for example. The square root of it would be 6. It's not worth my time to continue searching beyond the number 6 because I'm going to hit the repeats. So, you start from 1, you get 1 and 36, you go up, what would it be, 2 and 18 would be 1, I think 3 and 12, 4 and 9, 5 wouldn't be, 6 and 6, but then you start getting to 7, 8, 9, and we already did 9 and 4. We matched 4 with 9 from the bottom, and so by proceeding past that square root value of 6, we're not getting any new information, so we're going to cut our processing off there. In a recent video, we learned how to get a square root using our normal power method. Let's call it double root, and that will be equal to math pow for power, right? And then that'd be num, and then we found out we can do the reciprocal, right? If we wanted to square it, we'd put 2 there. If we want to take the square root, we'll take 1 over 2, which is 1/2. And that's what I'm doing here. So that'll help us search a range. Then we can loop. Now, normally we start at 0, right, with our loops, but I'm going to start at 3 here because we already covered the cases up to 2. So that's why I'm doing that. I is less than or equal to this root value plus plus I. That should do all the processing that we have to do. And then in here, it's simply a matter of checking if the number divides by whatever factor we're looking at from our loop, we know we do not have a prime number. So we could simply return false if this is ever true. If this ever divides out evenly, we know we have other factors besides the number 1 and the number itself. So I'm returning false there. And then, provided we survive that check, we're going to call the number prime. So that should cover our prime, and that makes the job appear a little bit easier then. So when we want to check for the next prime, you can do something like while not is prime number, you can increment the number, and this should break out when you have the next prime number. So by the time you break out, num will be incremented to where it's supposed to be, and then you can simply return the num. And there's probably a little inefficiency here, right? I don't know that we should increment by 1 every time, because we know even numbers are sort of drawing dead. So you could put in some kind of efficiency here. You know, we could do it out here. What if we did something like if num is greater than 2 and num modulo 2 equals 0. So if it's greater than 2, I didn't want to kill that special case where the number is 2, which is a prime number. So I don't want to catch that. If I do, I could just say if it's even, just bump it up by 1. And then every time in my loop, I could say plus equals 2, right? So we keep going for odd values. That should be a little more efficient. Return num. Yeah, I think this might do it. I probably need an include statement for, or a using statement for that math class. Let's give this a go. Cool. Yeah, it passed. So, as usual, if it's helpful, you can insert console write line statements in here if you need to see values as you're iterating through. But yeah, basically, we know outright that even numbers aren't going to work out besides 2. Start with an odd. Check if it's prime. If it's not, bump it up by 2 so we get the next odd number, because it's not worth our time to even process an even number. And then finally return. That is prime method. It helped us a lot by breaking this out, right? It made this next prime method pretty simple. Simple to write, simple to look at and think about. For is prime, we handled our special cases where we could outright say, you know, there was no point in looking at factors, right, for cases that we know about, these simple cases. Negative numbers, less than 1, an even number, we know right away, hey, no dice, this is not prime, get out of here. If it is 2, yep, you're prime. Again, no point in calculating the square root and trying to look for factors. So we're saying, yep, that's true. Provided we get past that, then we'll say, okay, let's go from the value 3, our first value that hasn't been covered, up to the square root, which would represent the largest unique factor from the bottom. And let's look at all those values. If the number divides out evenly with any of them, we know there's something other than 1 in the number itself. That's a factor, and by definition, then the number is not prime. If you survive that, the number is prime. So hopefully that's clear, but you know what to do if you have questions. Otherwise, I'll see you in the next video. Thanks.